OpenSpace is a NASA-supported open-source data visualization project that allows you to explore the entire known universe. Hi, I'm Carter Emmart, and I'm here to take you through this data visualization leaving EXPO from Dubai. We're going to fly out into an image here taken of Earth on September 21st, 2021. We'll quickly see the Earth coming into view with its beautiful atmosphere, as well as the satellites, low Earth orbit, and this 5-minute per second animation that we see right now, time lapse. And we're moving out through the GPS satellites and finally the geosynchronous band about 40,000 kilometers away from Earth. We now visualize the trails of the planets, as well as we can see the moon, 10 times the distance of geosynchronous, 400,000 kilometers, and the zodiacal constellations that array along the line of the Earth's ecliptic plane, the path of our planet around our star, the Sun. As we move out now, we can see the inner solar system, Mercury, Venus, Earth, Mars, Jupiter, Saturn, now the outer solar system, Uranus, Neptune, as we will now swallow up the entire solar system in the glare of our star, the Sun. Farther out, we see the stars charted in 3 dimensions against the veil of the galaxy itself. The Earth's coordinate system we draw as a sphere, some 80 light years in dimension, showing how far our radio signals have reached on out into space. The constellations now seen as stick figures stretching out to the distances of stars. Here, the blue that we see are data of where stars are being born. The yellow dots arrayed around the ancient star clusters around the center of our galaxy. And our galaxy, about 200 billion stars, 100,000 light years across. Our companion galaxies, the small and large Magellanic Clouds. The Andromeda Galaxy, about 2 million light years away. We see it 2 million years in the past. The light has taken so long to get to us. The dots you see here, each are another galaxy, at least the size of our own Milky Way, and the knots are galaxy clusters. We fade from one data set to the next. This is a Sloan Digital Sky Survey, about 6 million galaxies, and we can see this large-scale structure of the universe. The vacant areas are where we have yet to be able to map. Quasars are the youngest objects we see because the light has taken so long, and then finally the cosmic microwave background. This represents a spherical horizon around us that is the echo of the Big Bang, the farthest thing we can see, but also the youngest. It represents a horizon for our particular perspective in space. As not containing the entire universe, it's just the universe as seen from our perspective, bounded in time as well as space. As we fly back in, just mention that we're flying through the American Museum of Natural History's Digital Universe 3D Atlas. This was put together as part of the Millennium Project that rebuilt the Hayden Planetarium. We are very pleased to be presenting to you today in cooperation with Christie Digital of Canada. We have their latest Eclipse projector, high dynamic range laser projection, which in the planetarium, Hayden Planetarium in New York City, at the American Museum of Natural History, gives us an unprecedented view of space because the black itself is so black that the contrast of all of this makes this virtually real representation of the universe seem as though you were truly immersed in it. As we fly back home to the Sun, we're going to come back. We see our radiosphere once again. Rigel Kentaurus is the nearest star to us, better known as Alpha Centauri. And now, once again, we'll see our solar system re-emerge out of the glare of the Sun. But I've retargeted us. We left Earth, but we're going to go to the next planet out, our future, where many countries are aimed, including the United Arab Emirates and their HOPE spacecraft, which is now there, having arrived in February of 2021. This spacecraft has been mapping Mars in the atmosphere, and so we come up on Mars. We will now see it has 2 moons, Deimos and Phobos. Mars is half the size of Earth. It has a slight atmosphere, but the solar system's largest canyon, also the volcanoes off to the left, are part of this complex of volcanoes that includes Olympus Mons, the largest volcano that we know of in the solar system. This crack opened up from the bulge that also caused the volcanism of the volcanoes that we see. And this canyon would stretch from New York to Los Angeles or from Rome to Dubai, about 4,000 to 5,000 kilometers in length. As we come in, its length is also accentuated by its depth. This canyon is deeper than the height of Mount Everest. And as we come in, we see walls here that are easily about throughout this canyon here in western Candor Chasma, one of the canyons that make up Valles Marineris. These walls are on the order of about 7,000 meters. As we come down to what's inside the canyon, we see a very interesting area of layers. These are layered deposits from remote sensing from orbit. We've been able to tell that these are sulfurous deposits, sulfate mounds that were laid down possibly by lakes, possibly just by airfall from the sulfurous atmosphere created during the eruptions of the volcanoes about 3 billion years ago. These layers are exposed. They've been folded, but they have also been lifted up, and they've been eroded by the winds, literally over about the last 3 billion years. Mars went dormant about 3 billion years ago. However, we know that it had running water at the same time Earth had water, and the beginning of life was occurring around that time. So about between 4 and 3 billion years ago. These hills here are about as high as the Burj Khalifa, and then behind, once again, the canyon walls of several thousand meters. So I want to invite you all to come to OpenSpace and join us at the OpenSpaceProject.com. You can download the software in whatever flavor software you would like, and so you can explore the universe with us. Thank you very much.